Today's video is on piecewise-defined functions. What are piecewise-defined functions? They're functions which are defined by multiple subfunctions. Now, what do I mean by this? Well, let's have a look at an example of one. We have f of x is equal to, and we have three subfunctions here. Our first one is x plus 2, our second one is x squared minus 2, and our third one is x minus 2. These are our three subfunctions, and then behind them we get our domain. So for x plus 2 we have x is less than negative 3. For x squared minus 2 we have x is greater than or equal to negative 2 or less than or equal to 3. And for x minus 2 we have x is greater than 4. So let's look at an example, and your typical question on piecewise defined functions is to sketch the graph and find the range of your function. Let's have a look. We've got the same example we had just before. So we've got our three subfunctions, x plus 2. We're going to label that number 1. We've got x squared minus 2. We're going to label that number 2. And we've got x minus 2. We're going to label that number 3. And they each have their domains. And now that we've labeled them, we're going to start off with each function and then the next function and then the next function. So we'll start off with function number 1. We've got f of x is equal to x plus 2. And so what we want to do is we want to sub in the values that we're given in our domain into our f of x to find its points on the graph. So if we take f of negative 3, we know x is equal to negative 3, so it's equal to negative 3 plus 2, which is equal to negative 1. And so we know the point on our graph will be negative 3, comma negative 1. That's for our first equation. Our second equation, we have f of x is equal to x squared minus 2. And because we have x squared there, we know that it's going to be a parabola. First, look for our turning point, which is given to us by negative b over 2a. Except since b is 0, it just means that our x turning point is going to be 0. So we know our x turning point is equal to 0. Now, to find our y value on the turning point, we can sub 0 in. So if we do f of 0 equal to 0 minus 2, which is equal to negative 2, and therefore our turning point is equal to 0 comma negative 2. And so now we can do what we did with equation number 1, where we take our values in our domain and we sub them in. So let's take our first value, negative 2. F of negative 2 is equal to 4 minus 2, which is equal to 2. So there's our first value. And f of 3 is equal to 9 minus 2, which is equal to 7. And so we can write these as coordinates, negative 2, comma 2, and 3, comma 7. And those are our two coordinates. And we can also find our x-intercepts. Because it's x squared minus 2, we can just do a difference of perfect squares to get x plus 2 root 2 and x minus root 2. And therefore our x-intercepts are plus or minus root 2. And now we can move on to equation number 3. So we have x minus 2 where x is greater than 4, which is another straight line. So we can write f of x is equal to x minus 2. And now we can sub in our value of 4. So f of 4 is equal to 4 minus 2, which is 2. And so we get our coordinate point 4, comma 2. So now we can get our graph up and we can put our points on the graph. So let's start off with our first point. We have the coordinate negative 3, negative 1. So when x equals negative 3, y is equal to negative 1. And because it has a gradient of 1, and we're looking for all values of x which are less than negative 3, we can just draw our line like this. And now we can move on to our second point. We have 2 points since it's a parabola. We have negative 2, comma 2. So that would be here. And we have 3, comma 7, which is all the way up here. And we also need to put our turning point on the graph, which is 0, comma negative 2. And now we can connect these dots up. And for our last value, we have 4, comma 2, which is over here. It also has a gradient of 1, and we're looking for all of the values where x is greater than 4, so we just sketch it this way. So that's our graph. However, now we need to go back over it. We can see in some of our questions, it says greater than, or it says greater or equal to. So if it's greater or equal to, we represent it by a closed dot on our graph. But if it's greater than or less than, we put an open circle. So for x is less than negative 3, we're going to go back to our question and just make that an open circle. And same for x is greater than 4, we're just going to go back and change that to an open circle. And now we can find our range. So we know for y, because we have this coordinate going infinitely down, we know that's going to be negative infinity. So our range is equal to, when we're talking about infinity, we put a circle bracket, so we can put circle brackets, comma negative infinity. And then we also have our other straight line going all the way to positive infinity. So it'd be positive infinity, close circle bracket. And another way of writing this is r, saying that our range is all real values.